The function that you're going to analyze will work out a power of 2 using this strategy. Two to the n is equal to the n minus 1 brackets, plus 2 to the n minus 1. Now, if we're going to write a scheme function to do that, you have a function there, but I'm going to write it out because it makes it easy to analyze once on the board. And we'll define there's also a second implementation that I had planned to put in that didn't get there. And that second implementation actually had a function named double that works out once and then just double it. But don't worry about that right now.
I was starting type of error, so instead of n, one is n minus one, right?
Right, to the n minus
So
1.
it's not gonna be
So you may know that later down we'll make reference to two implementations. One of them actually didn't get it, I realized. So the second implementation would work this out once and then double it,
okay.
rather than having to execute the function twice. But we, right now, we'll just do the analysis on this version of it. Alright, so what would be the basic ops in this case?
Since we're having the minus twice, we count them for two times, right?
We identify them once. When it becomes time to count them, then we
Okay.
count them twice.
Plus one,
So the basic ops
equal sign,
equal.
addition,
Mhm.
and subtraction.
Actually, yeah, normally I may not be able to mark them on this because it gives the impression that you're counting. When I'm counting, I know to mark them on. But you know, I'm gonna write them down here. Equal. All right. So next step, identify set of input will be n, and then we now get to see your count instructions for each case. Granted, what you're analyzing in these examples, the cases are pretty clear cut, and one is obviously much heavier than the other. But there may be times when it comes to cases that have comparable weight. Now, when you're analyzing, you're normally looking, well, you can do different types of analysis. You can do a best case analysis, you can do average case analysis, you can do a worst case analysis. If you want to guarantee someone else that your thing will perform above a certain standard, you want to give them the worst case analysis. So the standard when you're analyzing software is to do the worst case analysis and then you report on the worst case analysis. I mean, there are situations where average case analysis is appropriate, but we'll get to those. So, of course, the best case analysis would be a situation where if you're one of those shady software developers and you fix the data before you go into the demo, you can always get the best case. It's easy once you work at it. So, counting instructions. Alright, if n equals 0, then n will be equal to suppose this was 5. Would that change your answer? Okay, very good.
It's not the number.
Exactly, it's the number of instructions. If n greater than 0, then the instructions that we're counting would be 1 here, 2 here, 3 here, and 4 here. And what else happens? There is a recursive call here and another one here. So we're going to be having t of n minus 1 here. So before plus t of n minus 1 plus t of n minus 1. So we write out our recurrence relation like this. 1,
You just add the two recursive statements to the n. When you have t of n is equal to 4 plus t.
Right. T of n minus 1 plus t of n minus 1. So the same thing.
But because you have the recursive statement, that's why you have two recursive statements at the end. There's two values. That's why you have that there.
Right.